Okay, more complex chain rule problems. Okay. If you look at what I have written here, just like a chain that you would have in the real world, you can add links to these problems so we can make them longer. You're just reiterating the chain rule. Okay, you work outside in, just like I told you yesterday. So if I want to rewrite, I got to rewrite this first. So now we can use the power rule within the chain rule. What's the most outside?
When you take the 2 off of x squared,
1/10.
oh, never mind.
Okay, this is the most outside. What's next? Well, this would be the next, right? And then you have this one here. Yeah, the most inside. Okay. So we got to start with the outside. One plus. Copy the inside. Okay, so we derivative of the outside is just the power rule there. Copy the inside. Now the derivative of the inside is another chain rule. That's nothing. So derivative of that. Copy the inside of it. And then take the derivative of that final inside piece. Okay, so you just keep going. Okay, I didn't color code it, but this would be inside number 2. This would be derivative of inside number 1. Any questions? All right, let's try one more. What's the outside function? Outside. What's the next one? Yep. And then x cubed is the last one. So derivative of sine is the outside cosine. And then copy the inside. Now derivative of the inside, what's the derivative of cosine? And then copy the inside. And then derivative of x cubed. You see how it just works outside in? Yeah?
Yeah.
Okay.
Oh, I was going to eat it.
Okay, we're going to get a little more abstract. I'm waiting for everybody to write. K of x equals C of D of x. It's a composite function. I didn't give you the function, but since it's a composite function, we have to use the chain rule. Okay. So again, we have to classify outside and inside. Yeah, they're two different functions. They're composites, just like the ones above. Okay, but they're just more abstract. So what is the derivative of K of x? Okay. Derivative of the outside, copy the inside. And then the derivative of the inside. It's just a little bit more abstract. What? What do you mean? Like right here? No, I copied that. Here or here? No, well, if you did the derivative of the inside, it would be 1, but you don't have to because it's 1. Okay. Let me write up a table here. So I've given you a table of values. Hopefully you can read it. It's kind of hard to read from here. And calculate K prime at -1, because X is -1 in that table. Okay. So we need C prime D of 1, sorry, -1, and D prime at -1. What's D at -1? Nope. D of -1 is 3. Because we're just in D here.
Oh, yeah.
Okay. D prime at -1 is -4. Now if I add another row here, we'll actually be able to get an answer.
What's C prime at 3? 0 times -4 is 0. So that's using composite functions and the chain rule when it's more abstract. Think you can handle those? Yeah, you're given the table of values. Do you think you could use that for the product rule? What do you want me to show you?
Yeah. Hey, can you go over number 26 from the spiral?
Okay, this will be the product rule. Okay, what's L prime? Okay, derivative of the first, copy second, plus copy first, derivative of the second. It's the same rule, you just got to apply it to some more abstract thought. Okay. We're good? You can also use the quotient rule there as well. Do you think you can handle that, or do you want me to show it to you? You can show it. That's fine. Okay, so now we have to employ the quotient rule. What's the quotient rule? Derivative of the top, copy bottom, minus copy top, derivative of the bottom, bottom squared. So you're generalizing these functions. Okay? Any questions? Toodles.